So thank you all for joining in on this online version. And I want to talk about data sketches. Yeah. So in general, I don't have much trouble saying no to something that I don't think I'll enjoy. However, saying no to something that seems really awesome, I am really bad at. And that's why I've had a to-do list besides my laptop, like literally over here, since I discovered my passion for the visualization of data. I do cross things off every now and then, but new items appear just as fast. However, in hindsight, I don't mind this permanent lack of having enough free time. These sort of personal projects have given me opportunities that I didn't even know I was looking for. And they also played a really big role in me being able to pursue a freelance career almost 3 years later. And my favorite personal project is the one I want to share more about today with you. And this was a year-long collaboration year eventually, but which I did together with Shirley Wu, who is like me also a database freelancer, but she's based in San Francisco and I'm in Amsterdam, so only 2 hours away instead of 11. And yeah, so to set the scene, a little bit of background. Shirley and me first met virtually in a database-centric Slack channel before meeting in real life a few months later at OpenBizConf, where we both had the honor to speak, and we really hit it off during those 3 days. And a few weeks later, I was publishing tutorials about the different aspects of my talk, and Shirley really jumped on them and started asking me all kinds of questions. And somewhere during those chats, we started lamenting the fact that we hadn't created as many more advanced data visualization projects in the previous year. And so suddenly, out of the blue, she asks me, well, do you want to collaborate and create stuff? And I think it took me only a few seconds to reply with all capital yes. And that's how Data Sketches was born. So in the next week, we figured out that we both liked the idea where we would create a visualization around a specific topic per month and do that for a year to see how two people would create two different visualizations starting from the same seed, that topic, and then diverging into different paths based on our own interests and history. Well, besides sharing the end result, we also wanted to write about the creation process, and we split that up into the three pillars that we find most important: data, sketching, and coding. And initially, we thought we could pull data sketches off with about 5 to 6 hours a week, but like real life really doesn't care about plans, especially coding plans, I find. So it took us a lot longer and a lot more time. And as the projects progressed and our technical skills became better, we wanted to do more elaborate things, and thus having to need even more time. And so eventually, it took us more than a year. But anyway, during this short talk, I want to take you through some of the lessons that I learned, challenges faced, and the insights that I gathered along the way. So a question that we often got was like, how did you find the data? But it's not really the data that leads us. It's really the topic of each month that first provides a spark of an idea, like an insight that we might want to reveal, and then how we could visualize that. And only once we have that more concrete angle do we investigate to see if we can find some appropriate data. For example, for November, the topic was books, which is pretty broad. But I really wanted to focus on fantasy books, and more specifically on the themes in titles of fantasy books. And once I thus have this sort of more concrete angle, I do nothing more special than just Google the web using that concrete angle in words combined with the words data and dataset, and then having the patience to click on every link in the first 2 or 3 pages of results. And this has led me to Google spreadsheets containing thousands of rows of Olympic medal winners and wonderfully unique data sets, such as one about the words spoken in the Lord of the Rings movies. Um, and even something about like a family tree of 3,000 people connected to European royal families, going back more than a millennia. I've also definitely learned that website design says nothing about the quality of the data it shares. You can find data in the weirdest places. And there are also places that share structured information, but not in some ready to download format. So instead, I have to scrape the logical layout of the website and put the information that it contains within a file with the help of some code. For example, IMDb has an advanced search functionality that returns a list of movies, and these movies are all contained within the same set of divs and other HTML elements. So I can therefore download the entire HTML of the page, and then use a script to search for anything that follows a very specific styling. All of the movie titles could be contained within a div that has a class of movie title, for example. And I did the same thing for that fantasy project, where I scraped the 100 best-selling fantasy author list names from the Amazon author rank instead of just manually trying to copy paste it all. So there are also APIs in which you can request information, but I have to admit I don't often use these because they can be a bit of a hassle to set up. Nevertheless, the wealth of information is sometimes just too good to ignore. So for example, I with these 100 author names that I got from Amazon, I then pushed them through the Goodreads API to get information about the books that they wrote, like the number of ratings and the average rating, and of course the titles of all of their books. Yeah, so that was pretty great. And of course, you can also create data completely manually, no code required. For our nostalgia month, I dove into something that I was really crazy about during my teens, Dragon Ball Z, and just kind of trying to get ideas. I was on the Dragon Ball wiki page, and I saw these lists that contained all of the fights that occurred during this anime, which is an anime revolves around fighting. So I thought that would be quite interesting to visualize all of these fights for an anime that revolves around fighting. So I just copy pasted all of these textual lists into Excel, and with the help of some of Excel's simple functions, split them apart into like who was fighting whom, and then added some other things. And it took me about 2 hours to get the data ready for these 200 fights, which I still think is a lot less time than if I try to write a scraper that would handle all of the nuances of the text in these lists. So what I hope to have shown here is that it's not just there's not just one specific way to find data. Data can be found in so many different ways, and it's not just data analysts that can find data. Sometimes you have luck and you can find a structured file with exactly that you need, but sometimes you need to scrape, and sometimes it requires a lot of manual labor. But I guess another important point is that even though you found your data, it often needs a lot of either cleaning or analyzing or restructuring to get it into the shape that you need to make it into a visual. And to dive a little bit more into what those kinds of adjustments could be, for August, the obvious theme at that time was the Olympics, and we were both big fans, so that made it easy. And I ended up visualizing all 5,000-ish gold medal winners since the very first games in 1896. So each of these circles is a group of similar sports, and we have like water sports and ball sports. And then within that, each of these slices or feathers in a way is one particular sport. We have like the first edition on the inside going outward to 2016. On the reddish background, we have the female events, and on the blue background, we have the male events. And then finally, each medal itself is colored according to the continent in which the country lies that won. So blue is Europe, red is the Americas, black is Africa, Asia is yellow, and then Oceania, never know how you say that in English, is green. And there are already some interesting things that I found from this. For example, I never knew before starting this project that tug of war was an official Olympic sport many years ago. And I'm kind of sad that we don't have like national tug of war teams anymore. I think that would be cool to bring back. Anyway, while I was working on this project, I found the data from 2 articles published by The Guardian for the 2012 games in London. And I was setting up my visual, and I quickly noticed once I had a visual that some of the obvious medals were missing. Like hockey was missing a medal in 2012, and well, hockey has 1 medal per gender, so that's a pretty obvious thing to see. So suddenly my confidence in this data set dropped drastically, even coming from such a respectable source. So I had to get an idea of the accuracy and completeness of the data, but I did not want to have to manually investigate 5,000 medals. I mean, this was still a personal project. So it had to kind of stay fun. So I found a proxy instead. On Wikipedia, I could find per edition, I could find the number of events that occurred during that edition, which I could then compare to the number of gold medals I had in my dataset. And if there was a discrepancy, I could investigate further to figure out where and why. And that's how I found out that, for example, the horses were also in the dataset, which made for an interesting read to suddenly see Princess and Sissy and Lady Mirka as women winning gold in the Olympics. Well, there were a few more of these sort of interesting things, so I made changes to the dataset, not too many though, but I got it back to a point where I trusted it again. So lesson here is, and I do have to relearn this one every once in a while, is that you need to get a sense of accuracy and completeness of your data. Missing data, I find, can be harder to trace or figure out that you have missing data than wrong data. And try and try and do like simple things like summations and averages, and then either comparing that to plain common sense, can an average be greater than some such and so percent, or just even better, comparing it to a different source. And well, Shirley also filled many pages of our notebooks with sketches because they help us think and lay out ideas beforehand. And my sketches are often very simple, really focusing on the main abstract shape that I want to fit my data into. It's just that I things like colors and layout and details. I do think about that vaguely, but not until I figured out that the shape will actually work once I've morphed it with the actual data. It's in the sense that, for example, with the Olympics project, I was inspired when I saw a peacock feather where there would be more emphasis on the later editions. But I had no idea if that would look all right once I finally placed 5,000 of these medals together. So I had to see if that would work before really moving on onto these extra parts. Um, and it took a few steps to kind of see and get that working. But once I had it into this state, which was still very sort of minimal, it's really just blocks and colors, I could already see some very interesting trends and patterns going on. So then I knew, it's like, okay, so this is working. Now I can really think about more of the other aspects of this data visualization. And something that I try and think about while sketching, I mean, besides coming up with the main shape, is how to add extra details, how to sort of create more context around the main insights that I want to convey. For example, with the Olympics project, it already has a high density of data, but I couldn't resist adding even more information about the Olympic and world records, because every athlete there tries to break at least a former, if not the latter. So I added a small white dot on a medal if it resulted in one of these records. And a way for me to think about adding these extra sort of variables is to think about the visual channels that I still have available after I have the main chart standing. Let me explain that even more with another example. So for the past 21 years, during exactly 1 week in the year, I believe I've once heard that more than half of the Netherlands listens to the same radio station. I mean, I know we're a small country, but that's still pretty unique. But this supposedly happens during the final week in the year, when the top 2,000 best songs ever are aired, counting down to the new year. I'm a fan. I've been listening for many years now, and that's why I really wanted to tackle these 2,000 songs. So I asked Shirley if our topic for December could be music. And in the goal that I had to visualize for this particular data set was to see what decade was most popular in terms of song release year. And here is the base visual, where each song is a circle, and they are clustered to sit at their year of release from the 60s until sort of today-ish. They're sized according to their position in top 2000 and colored according to the highest position they managed to reach in the weekly top 40s at that time. So that was a different data set. So we can already see that the most popular decade seems to be the 70s and 80s, and then something kind of went wrong during the early zeros, but we're seeming to get back up again. But yeah, there was so much more interesting information in this data set. Well, we had artists and bands and songs and much more. And I also found that the current visual was a little bit too visually boring for my taste. So I thought about, like, okay, so I have size and shape and color already taken, but what other parts can I use? And I decided to go for a stroke, adding extra marks on top and playing a lot more with textual annotations. So this is kind of the sketch that we made to think about these ideas and how to lay them out. And then sadly, during 2016, when I made this, David Bowie and Prince died. So I was like, I definitely want to show all of their songs and talk a little bit about how this selection changed with respect to the previous top 2000 list from the year before. But I could also use the rankings of these songs in different ways. For example, to highlight the most popular band, which is the Beatles, or to show which one is the highest one from 2016 from that year, who is the highest riser or newcomer, and to single out that Pokemon song. Or to even just make the top 10 songs appear more clearly by adding extra marks and textual annotations on top. So the thing is that even if your visualization is making the main point of the data insightful, in this sense, I found that by adding these extra details, it made the whole visual more interesting and visually appealing to look at. So it kind of draws you in more than the original one, and even adds these sort of extra marks and details because it was a static visualization, so you could not really do anything and hover over every circle. But yeah, so the lesson for me was to really try and add these extra layers of detail to the design by thinking about what variables do I still have that would be a nice to have, nice to know kind of thing, and would I could use remaining visual channels to actually visualize that on the data. So that you can give the truly interested reader even more ways to dive into and understand the information. But most of our hours were definitely spent on programming or making our visualizations. And here are two of my maybe less obvious coding lessons. So for our very first month, the topic was movies. And it was pretty clear to me early on that I wanted to do something with The Lord of the Rings, which is my favorite trilogy. And I thought that with the popularity of the movies that there would be loads of data available online, but that didn't turn out to be true at all. However, I did find one really nice, unique data set that contained the number of words spoken by each character in each scene of all three extended editions of The Lord of the Rings. And I thought that was so bloody amazing, I had to do something with that data set. So I took a step back and I thought, well, what would I find interesting? And then I thought, well, I would want to know how many words has each character of the Fellowship spoken at the different locations throughout the movie. But as you may be able to read from this screenshot is that there's no location information in it. So together with the scripts that I found online and my own memory of having seen the movies way too often, I just sat down on a Sunday afternoon and manually added location information to all 800 rows of Fellowship information. You know, a little dedication can go a long way. And then I started sketching IDs, and I quickly came upon one where the members of the Fellowship would be in the center, the locations spread around in a circle, and then these strings would connect them where the thicker the string, the more words spoken by that character at that location. However, this chart form, as far as I knew, didn't exist. Like, there was no tool that could easily create it for me. But it reminded me of something that did exist, which is a chord diagram. So I thought, well, maybe I can somehow transform the chord diagram into my sketch. So here we have a stripped of all text chord diagram. And so this one is based in D3. And I thought, well, if I can at least make these sort of chords flow towards the center instead, then I think I can manage to make this work. And thankfully, that actually took less time than anticipated. I'm a slow coder, but this was, Mike Bostock's code was very easy to sort of wrangle in different ways. So yeah, getting rid of the space and then adding in the actual Lord of the Rings data. We have some more appropriate color palettes than these. But yeah, we don't have one center. We have like 9 members of the Fellowship, so I had to make some space and vertical alignment. But according to my sketch, I hadn't really thought about this, but it was getting very squished in the center. So I thought, well, maybe I can just, there's a nice 50-50 split, so I'll just pull this stuff apart. But now I wasn't really liking the shapes of these sort of thingies going on, these strings going on, and that's when I finally took it upon myself to learn what SVG shapes are. So generally D3 creates these shapes for me, these SVG shapes, but now I was like, I want to learn how to do it myself so I can manually adjust these formulas on these shapes and these curves, which was the thing that took longest in this project, actually, learning how to adjust these curves. But that's how basically the chord diagram was transformed, mutated into this sort of new chart form in a way. You can also hover over things because there's a lot going on here to see what's really, you know, to get a little bit more focus on things. So in general here, The thing is, though, that even if you think you're making something new, it doesn't always mean you have to start from scratch, because a lot of people share what they did online in different ways and tutorials. So I always try and find the thing that most closely resembles my design and start from there, start adjusting that instead of just a blank something, whatever it is. And by it's just useful to use other people's or who have already thought about stuff and using that to as your sort of stepping point to move on from. And then my final lesson is one of my favorites, maybe. Um, ah, wait. Always this thing. There we go. Wrong lesson. My final lesson is the one that is about our nature month. So for February, the topic was nature, and I've always been intrigued to do something more along the lines of generative or data art. And the sort of the apparent randomness of nature kind of felt like a good connection. And then it also reminded me of butterflies and how their path across the page seems sort of across the page, across space seems kind of random to me. So I wanted to recreate these butterfly-like paths on a screen as well, and then base the paths on butterfly data. So in this sense, the wing color would be the approximate color on the page, and then the species would kind of define the line type. And then the bigger the butterfly, the thicker the line would be. And then using, I don't know, hundreds of semi-random number generators and inspiration by the works of Jared Harbaugh and Inconvergent, did I let my butterflies free across the screen. And this was really the only month in which I made no attempt to make the data insightful at all. I just wanted to create something that was based on data, but that would keep the audience kind of mesmerized as the screen would fill up with more and more butterfly-like paths. And creating this sort of sense of delight to keep your audience engaged can be a very important thing for data visualizations, especially once you get to create more complex visualizations. And they can be done in many very diverse ways. For example, I was once on a plane going home and I couldn't do anything critical really because I didn't have Wi-Fi. So I thought I'll just create an animated legend for my visualization about fantasy books instead of a static one. Or for the Dragon Ball Z project, which I sadly couldn't show, but I added these animated GIFs of the most memorable moments in Dragon Ball Z. Or for the music project, I did make a small interactive version where you could actually hover over each circle to see who it was, or even just turning the top 10 songs into tiny looking vinyls. All of these things were not, necessary per se. Or having one of my favorites is just adding annotations about weird and silly events. Here are the ones that happened for the Olympic Games, where Henry Pierce had to stop rowing to make way for ducks, and he still managed to win gold in the end. So it's really like, even though your main point is to make your visualization clear to your audience, try and also think about adding extra things such as animated legends and weird gifs and other things and small effects, as long as they stay like extra. They shouldn't take over the visual, but just these extra touches to keep your audience engaged and really make your visualization unique and fun in a way, and depending on the topic too, of course. So to end off, so during this project, I've learned that you can find data in the weirdest places. That it's not blasphemy to pre-calculate visual variables. That sketching helps weed out thinking errors, but that you can also sketch with code in a way. That SVG paths are really cool. Math is cool, and that surprisingly sort of small things can add a sense of delight for your audience. And we didn't set out to be confronted or learn all of these things. We just wanted to have fun. And in that, we definitely succeeded. But we did, especially once we both started freelancing, we realized that we'd taken on too much on our plate. So we went into a much, much slower sort of process. Instead of every month, we just did it whenever we felt for it, like it felt right. So it took me an extra year to finish the last two projects out of the 12. And Shirley only recently finished her final project. So it's like Data Sketches is finally done. And we're now in the next phase where we decided that we wanted to turn this into a book with all of these write-ups and add all of these lessons, like some of the ones that I shared with you now, and lots more things that we learned. So yeah, we hope that even though Data Sketches, like the online component, has been done, you'll hopefully be intrigued to maybe look into the book at some point. I know this is really bad that I do a plug in the end. It doesn't exist yet. Who knows? I hope it will at some time. But anyway, thank you very much for your attention.